Lasting impact, legacy, transformation. That's what innovators dream of achieving in their lifetime. Some achieve this with public fanfare, while others quietly dedicate decades of their lives to serving a mission bigger than themselves. Meet Lloyd Hackel. He joined Lawrence Livermore National Laboratory in 1976 and worked in the Laser Science and Technology program for 28 years. In that time, he met colleague Brent Dane, and together, they transformed industrial manufacturing in aviation and other industries by creating a new type of laser peening technology and then commercializing it with Curtiss-Wright's Metal Improvement Company, MIC for short.
Laser peening is an advanced technology of the 21st century that is replacing technology of 100 years ago or even older. The concept of the ball peen hammer, where you pound on a surface to put compression in, and that compression causes material to either stress or strain, some combination of the two. This is an example of curving aluminum. We formed wing panels for all of Boeing's 747-8 aircraft using the laser peening process to form thick sections of metal that could not otherwise be adequately formed. So the idea of the laser peening is it puts in the compression that ball peen hammer or shot peening would do, but puts it in much deeper than you can. Deeper means longer lifetime. Deeper means more curvature for a panel like this. In the laser we developed, 20 joules in 20 nanoseconds of output is equivalent output power of a nuclear power plant in those 20 nanoseconds. So basically, it was a major step forward in this type of laser technology, high peak power lasers. First major application was for the great big fan blades that you see when you board an aircraft. Those blades were failing, cracking, and actually breaking out in as little as 2 years. Since we started laser peening those blades 22 years ago, I believe not a single one has failed.
This work was the result of a Cooperative Research and Development Agreement, or CRADA, negotiated with MIC through LLNL's Innovation and Partnerships Office, or IPO.
Technology developed at the National Lab is at the cutting edge of where things will be. And so I think the interaction between the lab and industry is important from the point of view of understanding what technologies being developed at the lab could be applied to solve critical problems.
As researchers turned entrepreneurs, Lloyd and Brent both saw an opportunity to leverage the experiences they had gained at LLNL. They joined the MIC Regional R&D Center in Livermore in 2003. As the Vice President for Advanced Technologies over the past 21 years, Lloyd has never stopped innovating. Since then, the company has applied Lloyd and Brent's unique approach to laser peening as a way to greatly reduce maintenance costs and enhance safety for jet engines, improve the reliability and fuel efficiency of gas and steam turbine blades for electrical generation, provide crack-free life extension to the most significant military fighter jets, and dramatically slow hydrogen-driven cracking of metals, metal corrosion, and aid hydrogen storage capabilities.
Some of the applications take a decade or more to go from where you first understand the problem to actually deploying it. So you have to be patient with respect to it's just going to take time for people to adopt the new technology. I see the national labs as one of the places that leads the world in terms of advanced technologies that will be the next generation of components that will advance our lives and advance that of our children.